Hello, everybody. So, today we're going to be talking about graphing sequences. So, how this is going to be set up is we have a worksheet with a variety of different sequences, both arithmetic and geometric. Okay? We're going to be finding the explicit formula, even though we aren't using it, just to practice it. And then we're going to graph the sequences. Okay? So, we're going to start by just, again, reminding if it's an arithmetic sequence, the formula is a sub n is equal to the difference times n plus the zero term, right? And if it's a geometric sequence, it is a sub n is equal to the first term. So first term times the ratio to the n minus 1 power. Okay? So, like, those are the generic formulas, and then we plug in like the difference in the zero term and the first term in the ratio to write our specific explicit formulas for that sequence. Okay, so the first thing we got to do is we got to figure out if these are arithmetic or geometric before we start. Okay, so we're trying to figure out if we're adding or subtracting a number, or if we're multiplying or dividing by a number, right? So if I go from -2 to 0 to 2 to 4 to 6, like, it's just increasing by 2 each time, right? So that is an arithmetic problem. So I need to find two things. I need to find a difference and I need to find a zero term. Okay? Difference is easy. I just basically said it. It's adding 2 each time, right? So the difference is going to be positive 2. And then to get the zero term, you'd go back from the first term the same amount as your difference. So I'd go back 2 spots. So I'd go back 2 from -2, which is -4. So you would get -4 for your zero term. So your explicit formula is a sub n is equal to 2n minus 4. So that's my formula. And then to graph it, we're just going to plot out these things. So with arithmetic sequences, this is my first term, right? That's my second term, third term, fourth term, fifth term. The number of the term is basically going to be your x value. Okay? So I would start at 1, -2. I could also start at 0, -4, since that's my zero term, right? And then I would do like 2, 0. 3, 3 is 2. And then 4 is 6. Or 4 is 4. 5 is 6. And so on. Like, that's my sequence right there. And it is just a straight line, right? That's what arithmetic sequences are. They are linear lines. Because again, like, this is basically just saying mx plus b. It's the same exact equation, right? Y equals mx plus b. So sequences, if they're arithmetic, it's literally just a linear equation. Okay. If we look at the next problem, this one goes from 8 to 4, from 4 to 2, from 2 to 1, 1 to 1/2. So each time it's going down by a different amount. So that's obviously not going to be subtracting, right? So it's probably going to be dividing since it's going down. So what would I do to 8 to get 4? Well, I'm dividing by 2. But let's say I could have figured it out. I don't know what it is. So I can always just in my calculator do the second number divided by the first to figure out the ratio. So 4 divided by 8 is 0.5, or as a fraction, which is what we want, 1 over 2. So since it's a geometric sequence, I need to just find a ratio is all I really need to find, which was 1 over 2. It's just dividing by 2 or multiplying by 1/2. So the first term is pretty obvious. It's 8, right? So to write the geometric formula would be a sub n is equal to 8 times the ratio, so 1/2 to the n minus 1 power. And then to graph it, it's a little bit different than the arithmetic. Like, you would actually start at the y-axis at 0, okay, or at the first term. So, or am I doing that right? Nope, I'm wrong. Sorry. Nope, it's the same thing. So I'd start at 1. 1, 2, 3, 4, 5. So I would start at 1 for the x, and then I'd go up to 8, and that is my first number there. Okay? Then I would go to 2 and 4, and then 3 and 2, and then 4 and 1. So these are going by 2, so it's like halfway. And then 5.5, so just barely above 0. And if I connect these, what is my line doing? Well, it's curving, right? Because this is an exponential equation. So it's curving up there, and it is going flat right at 0. So 0 is where it's going flat. So it's just going to be a nice curved line, which is what all geometric sequences are, because those are literally just exponential sequences. So that you will notice that every arithmetic sequence is a straight line and every geometric sequence is a curved line. So let's look at another one. Another hint is if there's a fraction, it is most likely geometric. But this one starts at 116, then it goes 1, 4, and then it turns to 1, and then it turns to 4, and then it turns to 16. So we got to figure out what it is multiplying by. Now, if you look at the fractions, it can be a little bit confusing, but we could just look here and it goes from 1 to 4. What would you times by 1 to get to 4? Well, you times it by 4. So it's a geometric and its ratio is 4. Okay, so its formula would be a sub n is equal to the first term, 1 over 16, times 4 to the n minus 1 power. Okay, and then we would graph that. 1 and 116 is just basically right at 0, but not at 0, right? And then 2 and 1/4, it's again just basically right at 0. And then 3 and 1, so about halfway. And then 4 and 4. And then 5 and 16 is technically off the graph here. So it doesn't actually fit. But if we connect these dots, we can see it's a nice, very steep curve. And that's our line. Like that's literally it. You just plot the points. Like this is the x value is 1, x value is 2, x value is 3, x value is 4, x value is 5. Okay? Like that's how these sequences work. And it's going to be a hard day for you guys, I'm sure. Okay. I'm going to do just 3 more examples. I've basically gone over everything you need, so you can get working if you want, but I'm going to go over 3 more examples, and then I'll end the video. But I'll do these rather quickly, just so in case anybody's still struggling, you guys can kind of see me do a few more examples. So this one goes from 125 to 25, so huge drop there, and then 25 to 5. Obviously going by different numbers, so it's going to be geometric, and it's going to be a ratio, and since it's going down, it means it's dividing, right? And again, if we can't figure out what 25 to 5 is, like what you divided by, you could always just, again, do the second number divided by the first. So calculator 25 divided by 125 is 0.2, or as a fraction, it is literally just 1 over 5. So it's dividing by 5, but again, we write that as a fraction when we put it in our equation. So the ratio is 1 over 5, because that's what you would multiply. That would be the same as dividing by 5. So our formula would be a sub n is equal to 125 times 1 over 5 to the n minus 1 power. Again, first term and ratio with geometric. Then we would graph these. And again, like first term would be the x value 1, second term x value is 2, third term x value is 3, fourth term x value is 4, fifth term x value is 5, basically. Now 1 and 125 obviously is not going to fit. And 2 and 25 also does not fit. So we're not going to graph those points. But 3 and 5 will. 4 and 1 will. And then 5 and 1/5, again, just basically right at 0, will. If we connect those 3 points, what kind of line is it going to be? And I'm going to zoom in here a little bit so you guys can see. It's going to be a curved line, right? It's geometric. So I literally just kind of extend my lines, just like what we did with the exponential unit. Just extend the lines, the directions they're going. That's in the horizontal asymptotes, just right there at 0. Okay? All right, zoom out a little bit again. Okay? I'll zoom out a little bit more. Okay, let's do, ooh, I love this one. Okay, this one's a little bit tricky. So technically, you could call it either geometric or um, arithmetic, but it is, if I graphed it, it's obviously going to be arithmetic because it's going to present a straight line. Okay. So, and again, I'll just kind of graph it right now before I do the formula so you can see. Like this would be 1, 2, 3, 4, 5, right? So if I go to 1 and put a dot there for 4, 2, 4, 3, 4, 4, 4, 5, 4, I'm going to get a horizontal line, right? There's a reason why it is a horizontal line because the difference here, it's adding 0 each time, right? So we're going to call it arithmetic because it's a straight line. It's adding 0. My lights just went off, so now I'm spooky. Hold on. Okay, there we go. Gotta love those cost-saving measures. Save the electricity. Okay, so it's adding 0. It's not changing at all each time. So it is a 0 slope line, right? And then if I go back 0 from 4, I am still at 0. So its equation is literally a sub n is equal to 0n and then plus 4. So no matter what part of the sequence is, whatever I plug in for n, I'm just going to get 4 as my answer, which is why this line is literally just a horizontal line. Horizontal line right there. It is. And we're going to call that arithmetic. Now, again, like I said, I could say the ratio is 1, and I could do it that way where basically I'm just timesing everything by 1, and the geometric formula would technically work, but it is not a geometric sequence. That is an arithmetic sequence. Okay. Let's do one more. Let's look at number 11. Did lots of dividing ones. Obviously, this is going to be dividing because I just said that. But 49 to 7, I divided by 7, right? So this is a geometric sequence. It is dividing by 7, which means I'd write it as 1 over 7. Okay? Because that's what you do if it's dividing. You just write it as a fraction, 1 divided by whatever you're dividing by. And then your formula would be 49 times 1 over 7 to the n minus 1 power. A sub n equals. Almost forgot beginning part. Okay. And then 1, 2, 3, 4 is all the sequences I got. 1 and 49 obviously is not going to fit. 2 and 7 will, though, right there. And then 3 and 1 right there. And then 4 and 1, 7 is basically at 0. Again, we're going to get a curved line. And it's going to hug 0, as we can see. So it's going to hug 0, go all the way over there. And then it's just a very steep curve that direction. And that is all we are doing today. So if you have any questions, comments, concerns, tell your teacher. That's what we're here for. Don't just sit there. Okay. You guys are great. Keep being great, and I will see you out there.